Welcome to Path to Math. Today we're going to practice simplifying fractions. We're going to start small with the beginner problems and work our way up to more advanced problems. So to start us off, let's look at 2 over 6. The key concept with simplifying a fraction is going to be finding a factor that goes into the top and bottom of a fraction. So for this example, 2/6, I know 2 goes into 2 once, and I know 2 goes into 6 3 times. So what this looks like is you're essentially dividing the top and bottom by that factor that you find. So that's why our answer here is 1/3. We can simplify 2/6 to 1/3. Let's move on to 9 over 27. There's 2 ways you could do this. I'm going to start off small just in case that helps you out. We have 3 going into 9 and into 27. So I could divide the top and the bottom by 3. This is going to give me 3 over 9, which can further be simplified because I notice that 3 goes into 3 and 9 again, giving us 1/3. Now, if you notice off the bat that 9 goes into 9 and 9 goes into 27, you would have also gotten 1 over 3 as your final answer. So good job for you if you noticed that. Let's go to 84 over 160. This is a fraction where it can be difficult to tell a large number going into both of those because it could be in the 20s, it could be in the 40s. Don't overthink it. Just start with something small and keep working your way down. So for example, 2, right off the bat, goes into 84 and 160. And this is what I try to advise students as they practice. Just start small and then work your way down. So we have 42 over 80. 2 goes into both of those. We get 21 over 40. Now, I know 3 goes into 21 7 times. But how do I know if 3 goes into 40? I could tell very quickly if a number is divisible by 3 if the digits in that number add up to a number that is divisible by 3. This is what I mean. We have 40. We're trying to see if 3 goes into 40. So do 4 plus 0. That's going to give you 4. Does 4 go into 3? No. So it's not divisible by 3. Now, very quickly, an example of a number that would be divisible would be 126. So 126, let's say we had this over 3. It's a large number, so it's kind of hard to just glance at and tell. But if I add 1 plus 2 plus 6, what do we get? We get 9. Is 9 divisible by 3? Yes. So it's worth spending the extra time trying to figure out if 3 goes into that number. Okay, so you can figure out how many times 3 goes into 126 using some mental math. For example, I know that 3 times 40 equals 120. And then 3 times 2 equals 6. So 42 equals 126. And so that's what that fraction was simplified down to. But that's a quick little tip there for finding out if a number is divisible by 3 or not. Going back to our fraction, 21 over 40, that would be our final answer. Even though it doesn't look like a good final answer, that's as simplified as it could get. So moving on to variables. This is where it gets kind of fun. Let's throw in the letter x somewhere. 4x over 6. Now, we could treat the numbers separately and don't overthink the letters. I know 4 over 6 simplifies down to just 2/3. But does the x disappear? It does not. The x is going to stay up top. And so that's my simplified version of that fraction. What happens if we have an x up top and down below? It's the same rules with the numbers. We know that's going to be 2/3. But what happens with the x's? In this case, they're going to cancel. What's going to happen with a matching letter is you're going to want to subtract the exponents. And for these x values, there's an invisible 1 in their exponents. Whenever you have a matching base value, you are essentially subtracting the exponents. 1 minus 1 is 0, and x to the power of 0, or anything to the power of 0, is just 1. And that's why they essentially just cancel. So our final answer is just 2/3. No more x's. All right, let's do 4 times x to the 5th over 6 times x to the 7th. Here's where it gets interesting. So the numbers are the numbers. That's going to be 2/3, right? 2 goes into 4, 2 goes into 6. We have to subtract those exponents, and the difference between those exponents is 2. But am I going to put my x to the second power up top or down below? That's a decision that you have to make on your own. Now, the shortcut to knowing whether it's on the top or on the bottom is follow wherever the larger exponent is. Now, if we look back at our fraction, we have 5 and 7. The larger exponent is down below. So I have to take the x squared and put it down below as well. My final answer is going to be 2 over 3x squared. Understand that the difference of those exponents, the 5 and the 7, that's going to become your new exponent for that same value. Let's throw in the letter y. Let's do 12x to the 4th, y to the 7th, all over 3x, y to the 2nd. Okay, one thing at a time, right? We can focus on the numbers first. The 12 over 3, that's just going to become 4 over 1, because 3 goes into 12 4 times and 3 goes into 3 1 time. Focusing on the x values, we have 4 minus 1. Don't forget the invisible 1 down there. So we have x to the 3rd power. I put the x to the 3rd power up top because the 4 is what is on top. The larger number is on top in that case. Now let's look at the y values. We have y to the 7th, y to the 2nd. The difference between those is 5, and I'm going to be putting that to the top of the fraction because the larger exponent for the y values is also on top. So my real final answer here is just 4x to the 3rd, y to the 5th. No need for a fraction bar. All right, awesome. Let's move on to change of base. When simplifying a fraction with numerical values such as 9 to the 4th over 3 to the 6th, we can't automatically subtract these exponents. This would be similar to having x to the 4th over y to the 6th, and that's something you're not allowed to subtract. We have different values for the base value, the x and y. Same thing with the numbers. We have 9 and 3. Those are different values, so we can't subtract the exponents. What you can do, however, is you can rewrite the 9 as 3 to the 2nd power, because we know 3 squared equals 9. This is going to be very helpful. Let's go ahead and plug that in to the 9 value. So I have 3 squared parentheses to the 4th power all over 3 to the 6th. So I can't simplify anything yet. I have to do power to the power first. We have an exponent to an exponent. All you have to do with exponent to exponent, aka power to power, is multiply those exponents. So we have 3 to the 8th over 3 to the 6th. And now we're in business to actually subtract those exponents, which is what we practiced a little bit ago. So we're going to end up getting 3 to the 2nd power, and we know that that's just 9. So in this case, all of this simplifies down to just 9, and we have to be able to do that without a calculator for most tests, whether it's in school or on the SAT. Let's try another one. Let's do 16 over 2 to the 7th. So 16, believe it or not, can be rewritten as 2 to some kind of power. 2 times 2 times 2 times 2, we get 4, 8, and then 16. So I know that 16 can be rewritten as 2 to the 4th power. Now I could subtract the exponents. I'm going to have 1 over 2 to the 3rd, and I know 2 to the 3rd is 8. So my answer in this case is 1/8. All right, this is where it's going to get pretty difficult here with fractions. Let's practice fractions that have terms. Terms refer to the separation with a plus or minus sign, separation of values with a plus or minus sign. So let's start off with something relatively small. Let's do 4x plus 8y all over 4x. A lot of students, including myself, I've been a victim of this, are going to want to cancel out the 4x's, but you can't. That's kind of like, that's what I call is cherry picking. You can't necessarily isolate those two and cancel them. And the reason why is because the numerator is all together here with the plus 8y. You can't forget the plus 8y. Does 4x go into 8y? It doesn't, because the variables don't match. So we have a big issue here, but there is a way to simplify this. What you have to do when you notice what you have to do to simplify a fraction with terms, when you notice a plus or minus sign, is you have to typically do or use the GCF. You have to find out what the greatest common factor is on the top or bottom of a fraction, sometimes both. In this case, we have a plus sign up top. And so that's where we have to perform the GCF. Looking at that numerator, I know 4 goes into the 4x. I know 4 goes into the 8y. That's going to leave me with an x plus 2y once I pull out the 4 from each of those terms. If you need review on GCF, I have a video on GCF, so I won't spend too much time on this video. I'll link the GCF video down below. Now, to complete the simplification of this fraction, I am allowed to cancel out the 4's. And the reason why is because we're in a situation where this 4 up top is being multiplied by the entire rest of that part of the fraction. So in this case, the 4 is being multiplied with the entire numerator. When you have multiplication, that's a great sign. That's actually something that you want to see in fractions. You want to see multiplication between different groups. We have a group which is just the 4, and then we have a group which is x plus 2y. Having these two separate groups multiply together allows us to cancel out the 4's top and bottom, giving us x plus 2y over x. Now don't go and cancel out those x's, you're breaking that rule. This x is not being multiplied by the rest of the numerator, the x on top. The x on top is actually being added with the rest of the numerator. The only way to further simplify this fraction is to split the fraction. You are allowed to split a fraction based on the numerator. You can never split the denominator, but you can do this. Split the numerator. Notice how the denominator stays the same for each of these two different fractions that I created, but basically you could take the terms and duplicate them into two different ones. Now from here we have x over x. That's just going to become 1. And then the 2y over x cannot be simplified, so you're still stuck with that. That's a good final answer. However, x plus 2y over x is also a pretty good final answer as well. You might see both of these as potential answers on your test. The key takeaway when dealing with terms in a fraction is you're going to want to look for a GCF of some sort. Let's do another one. Let's do 3x squared y plus 4xy squared plus 3xy all over 12xy. Take a moment on your own and try to find a GCF for that numerator. So the GCF is going to be xy. Xy is the only thing, the only value that goes into each of these three terms. Don't pull out a 3 and don't pull out a 4. What I'm left over with is 3x plus 4y plus 3. And all that's going to be divided by 12xy. I don't have to find a GCF for the denominator because there's no separate terms. That's just one term. One term. And again, the keyword term, that's coming from the plus or minus signs. That's the red flag that you're looking for. Okay, now that I factor the numerator, I could cancel out the xy's top and bottom. That's going to give me 3x plus 4y plus 3 all over 12. Don't fall victim of that number 12 being the product of 3 and 4. What I'm trying to say is you can't cancel out the 3's with the 12. You can't cancel out the 4 with the 12. You can't cancel out any of that because you can't pull out a 3 or a 4 in that numerator. So it's tempting, but you're essentially stuck with what we have, which is 3x plus 4y plus 3 all over 12. And so that's what you're stuck with. That's going to be your final answer for this one. Let's move on to factoring. You can see polynomials inside fractions. The telltale sign that you're probably going to have to factor is going to be the denominator having two terms. Something that like this. Something that looks like this. X squared plus 5x plus 6 all over x plus 3. So notice how this time my denominator is two terms. That's a hint that we have to probably factor the top, factor the numerator. And when I say factor, whoops, that should say plus 6. I'm not talking about a GCF anymore. I'm talking about finding two numbers that multiply to 6 and add up to 5. This is going to be quadratic factoring. I cover this in another YouTube video. I'll link that down below as well. Now, to speed through, I know that 3 and 2 are my factors for that top. So x plus 3 times x plus 2 is my result after factoring the numerator. Down below, I don't change anything. There is no GCF down below, and there's nothing to factor out. This is good news for us, though. Notice how we have a matching group. This might feel uncomfortable at first, but understand that we have an x plus 3 on top and down below. We are allowed to cancel these guys out because up above, that x plus 3 is actually being multiplied to the rest of the numerator. It's almost as if we had 4 times x plus 3. If we have a 4 down below and a 4 up top, in this case, you should have confidence in being able to cancel those out. Now, with the groups, it's the same rule. The x plus 3's completely cancel out, leaving us with just x plus 2. Moving on, let's do 3x squared plus 12x plus 12, all divided by x plus 2 squared. All right, so a couple things going on here. The first thing you want to do is you want to jump on any opportunity to factor a GCF, a greatest common factor. The GCF of the numerator is going to be 3. 3 goes into every single one of those terms up top. So we have 3 times x squared plus 4x plus 4. All divided by x plus 2 squared. But we're not done. Sometimes you have to factor twice. That polynomial, that quadratic, x squared plus 4x plus 4, can be factored further. 2 can be multiplied by itself and added to itself to give us the numbers 4 and 4. So what we want to do is we want to rewrite that as x plus 2, x plus 2. One more step to help us see what happens is to rewrite the x plus 2 times x plus 2 as x plus 2 squared, because we know anything times itself can be rewritten as itself squared, like 4 times 4 equals 4 squared. So don't be intimidated by the fact that we have a group here. We can still write it as x plus 2 to the second power. Hopefully now you can see that those groups completely cancel, top and bottom, making our life a lot easier. Our final answer in this example is just 3. Now briefly, what if we had 3 plus x plus 2 squared, all divided by x plus 2 squared? Then what would you do? Could you still cancel those x plus 2's? No, you can't. That plus sign, remember, that plus sign is a red flag. That means you can't cancel top and bottom. In this case, in the first example, we have 3 times that group, x plus 2. And that's where multiplication comes in and saves us. All right, that'll wrap up for factoring. Let's move on to some practice problems where I'm not going to tell you what can or can't be done. I'll just explain to it after. So maybe this is the simplified form of this problem, or maybe there is some simplification that can be done. I want you to challenge yourself and tell yourself if this is as simplified as this fraction can get, or if there's any simplification that we can do further to this fraction. This is the best way to learn, is trying on your own. All right, so the answer to this one is this is as simplified as it could basically get. Okay, there's no way to cancel out that x value with anything. We can't cancel out the x values in each of these. Don't do that. Don't have 1 plus 2 times 1 plus 5 over 2. I hope you didn't do that. It's okay if you did. You got to learn from your mistakes. The reason why we're not allowed to do this is because the x's are within the groups, and those groups don't match top and bottom. If we have something like this, x plus 3, hopefully you could see how you can't just take the x value from this group and cancel it with the other groups. When there's groups involved, that I keep saying that word groups, the parentheses involved, you have to have a full perfect match. You have to be able to match them top and bottom, like a puzzle piece. So when we have the 2x, there is no matching group to the top, and so we can't just cherry pick those x values and cancel them out. Unfortunately, that's as simplified as it gets. What they might expect you to do is they might expect you to FOIL. So let's FOIL that numerator. All right, so we have x squared plus plus 2x x squared plus 2x plus 5x plus 10, all divided by 2x, and then I can combine the like terms in the middle. That's x squared plus 7x plus 10, all over 2x. Anything we could cancel out here? No. I hope you said that sternly. That's a strong no. That would be the alternative answer to this problem, but there's really no other legitimate simplification we could have done to that. All right, how about this one? So that's 2xy minus 8x down below. Try this on your own briefly. I'm going to share the answer right now. So down below in the denominator, there is a GCF we can pull. Understand that there's two terms in the denominator. Typically that means we have to factor the numerator, or there might be a GCF down below that we could pull out and hopefully see a matching group. The GCF down below is pretty tough. It's going to be 2x. I'm going to rewrite the numerator. I'm not changing anything for the top of that fraction. Down below, 2x goes into the first term and the second term, leaving us with y minus 4. Because if we pull out a 2x from the 8x, all we're left with is just 4. All right, so y minus 4, top and bottom. I absolutely can cancel those groups out. I have multiplication happening between these two groups up top as well as these two groups down below, and furthermore, we have a completely matching group. So the y minus 4's cancel out happily. Now we're left with 2x plus 3 over 2x. I am not about to just cross out the 2x's, because up above we have 2x plus 3. We no longer have multiplication happening between groups. We're back down to just addition. So if I want to, I could split this fraction. Splitting this fraction would become 2x over 2x plus 3 over 2x. Now the 2x's will then cancel because they're all by themselves in a fraction. That'll become 1, and then we're still left with 3 over 2x. So either that, the 1 plus 3 over 2x, or 2x plus 3 over 2x are both viable final answers for this problem. All right, one more practice problem here. Let's do x squared minus 4, x plus 3, and then 3x squared minus 12. Try this on your own again. All right, I'm going to do the answer now. Again, there is a GCF down below. We have two terms. There is a GCF of 3. Rewrite the top. Down below, we get x squared minus 4. And now, hopefully, you can see the x squared minus 4's quickly cancel. And we have x plus 3 over 3. Again, this can be rewritten by splitting it. X over 3 plus 3 over 3. X over 3 plus 1. Both of those are good final answers. All right, I hope this helps you with your practice problems with fractions. I know simplifying fractions can be really difficult. Any questions, let me know down in the comments. Any further content that you want to see, let me know down below and I'll dedicate that video to you. I appreciate the support. Good luck on the SAT. Good luck on all your school adventures. And thank you for supporting Path to Math.